everybody to the first OLOFOS seminar, which I will be organizing, and I will be also speaking in the first OLOFOS seminar. Sorry for that, I did not have the intention to give myself this stage, but I did not find a speaker for the first session, so I'll present some recent work I've been working on that some of you might find interesting, and so this was an opportunity to do it. Maybe it wouldn't be more fit for the WIP service, WIP seminar, but I think it also fits the profile of an OLOFOS lecture. So some disclaimers. This is work in progress, at least part of it. Some things are quite well established, but especially about the more philosophical sides, there is still a lot to be done, and I don't consider this at all as being a final proposal or something like that. So as always, all comments are very welcome, but specifically if you want to collaborate on something like this, or you find something interesting there, or you find something super problematic, it is extremely welcome. It's a kind of new research topic for me, so especially the quantum stuff that is in there, I'm still not a complete specialist on it, so some of you are much more competent than I am, so especially there, I don't want to claim too much authority over these matters. But despite that, I do think that there is something in it. It's not that I'm going to waste 2 hours of your time with some loose thoughts. This is really something that I would like to be a direction for future research, and there could be many things in there, or just a few. Let's see. So what do we aim at with this kind of project? Well, it's mostly to provide some insights in the notion of indeterminacy, and how to combine this with classical logic. So indeterminacy, very simply put, some sentences, some propositions lack truth values, and in classical logic you have excluded middle, so everything has to have a truth value, at least according to standard semantics. So what can we do to make sense of a metaphysical picture in which there are these gaps, there are these really lack of truth values at some points? How can we even make sense of such a metaphysics if our standard logic that we use in metaphysics is classical logic? Are we really being completely honest if we talk about some form of indeterminacy and we don't specify that we're all of a sudden skipped changing the logic and the basis? Like, how can we deal with this combination of trying to, well, stay intelligible and not just start using another language, another logic, but still to be able to account for real phenomena. So the problem of like dealing with logic and metaphysics at the same time is a little bit at the core here. And quantum mechanics, because of some, you will see later, orthodox quantum mechanics could be seen as quite a good test for what some have called deep indeterminacy. And this is, and if I forget it, I'll say it now clearly. This is not at all to defend orthodox quantum mechanics or something, or think that that's the best interpretation you can give of the world, but just as a test case of a way to look at the world that seems to work very well, that seems to give us a very stable set of predictions, and has a very well-developed formalism behind it. There's big conceptual problems on the sides, but the basic instrumentalist framework works very well. And still, to some extent, it is obviously indeterminate. It shows obvious indeterminacy. So maybe we will get rid of orthodox quantum mechanics at some point, or we should accept another interpretation for it, or whatever. But that is sort of besides the point of this talk. It's like we have a case where indeterminacy is instrumental, in an instrumentalist way, treated very understandably in something that looks like classical mathematics. How is that, and still there seems to be indeterminacy. What's happening there? And I would like to shine a new light on this. I think it's useful to shine a new light on these phenomena from exact truthmaker semantics. That's the original part of the talk. And also, this new light could be then shined on other cases of indeterminacy, maybe. Okay. Concretely, what we will do, we will distinguish epistemic, semantic, shallow, and deep indeterminacy. Now we will show why orthodox quantum mechanics requires deep indeterminacy, according to Bradford Skow. Sorry, I always forget his first name. Skow, in any case, Bradford Skow. Yeah. He has written a cool paper on deep indeterminacy in quantum mechanics. We will go over that very briefly. Then we'll introduce truthmaker semantics and see how that can be used to deal with indeterminacy. We will show that quantum mechanics formalism fits with this semantics, that it's compatible with it, get the same results than ordinary Hilbert-style quantum mechanics. And then we suggest some directions to take this model to other applications outside of quantum mechanics. So it is not about quantum mechanics. Quantum mechanics is just an example because it's what Skow used to show his case of deep indeterminacy, which we will be interested in. So some definitions you could call defined in a very kind of a modest way indeterminacy as just a sentence lacking a truth value. It's epistemic indeterminacy when the sentence lacks a truth value because of epistemic reasons. Maybe because some value is unknowable, inaccessible, or maybe just unknown to some system. It's the idea that, well, basically there is a truth value out there in the world to some extent, and it's the limitations of the epistemic agent, the epistemic system, whatever, the thing that tries to represent the world where the indeterminacy lies. So it's a case of not knowing the truth value. It doesn't have to be knowing, it can be other epistemic relations, but always the indeterminacy is not associated with something, some deeper indeterminacy in the world. It's a lack of it's a hole that can be filled, one could say. It's a lack of information that can be in principle receive a value. Semantic indeterminacy is a more interesting phenomenon where the problem lies in language. So there is still a sentence without a truth value, but the problem is in language. So it's language being imprecise that makes it that some sentences do not get truth values. This is what they call vagueness. One might think of cases like being bald. Is a person with 1,000 hairs bald or not? And one could claim that this is not determinate, that the concept itself does not specify whether this person is bald. We all agree that with somebody with 0 hairs is not bald, and is bald, and somebody with 1 million hairs is not bald. The concept clearly specifies that, but it does not specify the truth value of somebody with 1,000 hairs is bald. There's a lot of vague words in language, obviously. I guess you all know that. The idea here is usually that this has nothing to do with some features of the world. So this person has a fixed number of hairs. There's no worldly feature that is lacking about this person. It's just that our language is imperfect. And that makes it the case that some sentences lack truth values. That's semantic indeterminacy. And then there is what they call metaphysical determinacy. And that is the case where the sentence lacks a truth value and it's not for epistemic or linguistic reasons. So there must be something deep going on. Now, the question doesn't have to be metaphysical because it's a purely negative definition. And I think it's, I want to make a methodological claim here that it doesn't have to be metaphysical. And I think it's actually useful to study, at least formally, the phenomenon beyond metaphysics. Because I don't think the kind of phenomena that we should be interested here are so related with it being worldly, which the word metaphysics suggests, that it's about the determinacies in the world. But it could just be a feature of a theory, why not? If Bradford Skow makes an argument about quantum mechanics being metaphysically deeply, showing metaphysical deep indeterminacy, then, I mean, he's talking about quantum mechanics. It is still interesting to make that point, even if it would happen that it's completely the wrong theory for the world. So maybe our best, some useful theories we have to talk about the world or about something else show some indeterminacy that is not related to linguistic issues or to epistemic issues. That's a possibility, and that those theories would nevertheless be interesting, despite that indeterminacy that is not to be solved by epistemic or by linguistic means. And so, my talk is not about metaphysics, it's about the way we analyze theories. And we could think of fictional theories that might be pleasant or useful to us, where fiction is a typical case where would have indeterminacy. So some features of Sherlock Holmes are very well documented, of course. But the number of hairs he had at a given day, of course, that is a feature that is, say, indeterminate. There's no true value to it. That could be a case. I mean, you can debate about that. There's a lot of debate in literature. You could also say that, no, this is a classical world where Sherlock Holmes lives in. It's just that we don't know what the true value is, but there is one. You can think of it in mathematics. You could have a non-realistic view on mathematics, like structuralist or whatever, constructivist, and think that a thing like the continuum hypothesis or something else, maybe the axiom of choice or something, or other axioms, maybe the Gödel sentence, those things don't have true values. And that has nothing to do with our lack of knowledge. There's nothing to do with the language being imprecise. The language is quite precise. It's mathematics. There is no way for a non-realist to know anything more about the continuum hypothesis than we know through our mathematical constructions. So you might say that that is a case where there is a sort of deeper sort of indeterminacy. And of course that's not worldly, because I'm taking the case of a non-realistic view on mathematics. So this mathematics is not talking about the world. Is it metaphysics? Well, maybe borderline, but certainly not like realistic metaphysics. Same for idealized scientific models. If there's a scientific model that is supposed to approximate how the world is like, and it shows an indeterminacy, but it's an idealized model, so it's not that we can that we lack knowledge about the model. The model is an abstract thing. We can have extra knowledge about the world it's trying to describe, but we know that it's not exactly describing the world. If there's an indeterminacy in there, maybe that is of a similar kind. And here we are not at all thinking that the indeterminacy is worldly. Quite the opposite, because we take the idea of an idealized scientific model. So we can do all of that without requiring those to be true in a correspondence theoretic sense of the word. So so in that sense, those things can be super interesting to study, can show indeterminacy, but have nothing in a very strict sense to do with metaphysics. So I think the term metaphysical indeterminacy is maybe not very useful to make the study of this phenomenon go through. Yeah, I said that already. So, well, conclusion, we better call it ontic indeterminacy or something than metaphysical indeterminacy. It's also just a word, but the definition is the negative description. It's not semantic, it's not linguistic, it's not semantic, it's not epistemological, but it's lacking truth value. So why is ontic indeterminacy so mysterious, it seems to me? And one of the aspects could be that metaphysics or ontology in general accepts classical logic. Classical logic just forces you to accept that all meaningful sentences have a truth value. So the problem that you're seeing, that some sentences lack a truth value, is simply not coherent with your basic presuppositions. So the problem itself cannot even be formulated, I would say, in a traditional classical framework. And that makes it very hard to grasp what we're talking about. We're really not, I mean, so a sentence does not have a value. What does that mean? You can say, oh, I don't know it, but that's not what we want to talk about. Does it mean that that there is a proposition and the actual world is not in the proposition nor in its complement? No, that's impossible, because the complement of the proposition is all the worlds that are not in the proposition, so it has to be somewhere. So just to make sense of it itself from a traditional point of view is very hard. And at the same time, we are used to working classical logic. We don't want to just get rid of it because we have some apparent ontological or metaphysical problem. And one of the tools to do this is supervaluationism. It's mainly something to deal with semantic indeterminacy. Semantic indeterminacy is the phenomenon where you where you have indeterminacy for semantic reasons, and the way supervaluationists deal with that is that we're going to be interested in all admissible way to make something precise. So say that we have some spectrum from not bold to bold. And those cases here are clearly bold, and those cases here are clearly not bold. Then we have here some gap where we don't have a truth value. But supervaluationists say, well, basically how we can deal with that is by dealing with the precifications of it. I'll mispronounce that word 1,000 times. It's a horrible word. Precifications, and the rest of the time I'll say precifications. But then you know what I mean by that. So how do we understand precification? So there is a bunch of ways you could make this vague predicate precise. You could put the border here between bold and not bold. You could put it here. You can put it here. But if there is a classical model that puts the border here, then this is not compatible with the normative content of that concept. So we have to exclude this model. But these are acceptable precisifications. But they are perfectly classical. So here the not bold case is still there, then the bold cases, there's no lack of truth value. So we can use classical logic perfectly within these precisifications. This is also a classical model, but it's one that is excluded by the concept we use. And so then, how do we get to this? Because this is understandable. How do we get to this? Well, it's basically using the box operator in modal logic. So all possible ways to make it precise, like you say, the box operator talks about all possible worlds. Here you say something is true if it's true in all possible precisifications. It's false in all admissible precisifications. There's several advantages to this. First of all, you can keep your classical logic locally, so to say. And on top of that, also your logic remains classical in the sense that all tautologies of classical logic will be super true here, in the sense of true in all possible, in all admissible precisifications. So A or not A, for example, is clearly true in all of those. Or bold or not bold, the statement John is bold or not bold will everywhere be true. So this classical tautology, together with all the rest, is going to be super true. So you keep all the classical tautologies, and also you keep classical logic with respect to preservation of supertruth. So usually classical logic is defined as preservation of truth. Like the premises, the conclusions are true if the premises are true. But you can formulate a similar thing for supertruth. The premises are super true if the conclusions are super true. And that preserves all rules of classical logic. Now, there is something what they call meta-inference rules that are not surviving this trick. So it's a bit of a lie, it's a too cheap marketing trick to say that it preserves classical logic, but it preserves a good bunch, a good part of it that at least makes it capable to do some deductions inside of it and so on. So that's the main advantage of this theory for vagueness. But that's for the semantic indeterminacy. So clearly, this person that is either bold or not bold has all its features perfectly defined. It's just that our language shows some doubt about where the borderline lies. That's all. So can we use that trick to talk about ontic indeterminacy? And of course, the answer is yes. People in the literature have done that. Sorry, I forgot their names. William. Sorry. It's in the abstract that I sent. So you can think of what then Bradford Skow will call shallow indeterminacy, and it's basically metaphysical supervaluationism. So it's kind of you think now if the gap is worldly, you cannot of course make it precise. There's nothing to be made precise. But what you can do is think of ersatz possible worlds. What are ersatz possible worlds that are not like the David Lewis kind of real possible worlds that exist, They are just sets of sentences that are consistent and complete. They have the same logical, they make the same things true as real possible worlds, but they are just basically sets of sentences. They are like mathematical objects. So you have these sets of sentences, you call them as possible worlds, and you say that an as possible world is called actual if it is compatible with the real worlds. And now, in cases of this shallow indeterminacy, as Skow calls it, you have this indeterminacy if there would be several as possible worlds that are compatible with the real worlds. So the real world is what it is, but the kind of conceptual framework that we stick on it, that is complete, there are several of those that fit onto it. And the case that is, I guess, the most easy to explain is where a person or an object goes into fission. There's a typical metaphysics people talking about cases like that. So you have an individual, it splits into two identical individuals over time, and it's so then you can wonder, is this person identical with that person, or is it identical with that person? And there is no truth to that matter. And you could say, well, if this circumstance occurs, then basically both statements can be part of an as possible world that is completely coherent, and both of them are coherent with the actual state of affairs. So these are extremely simple and fabricated cases, of course. But you could also apply this to things like paradoxes of truth, where you have the truth teller. So the truth teller is the sentence that says of itself that it's true. This sentence can both be false and true. And there is really no value to this sentence that is well defined, or they both compatible, both the reading where the sentence is true and the reading where the sentence is false are perfectly compatible with the world, the real world. So this could be a trick to deal with this shallow indeterminacy that is ontic. And then you're going to say that something is true when it's true in all as possible worlds that are compatible with the real worlds. So this keeps this like the features of this framework, because it has the same logical structure, are identical to supervaluationism. You can still keep a lot of classical logic. These as possible worlds are just classical worlds. But then Skow says, well, this is cool to deal with some nice cases, nice symmetric cases where you cannot make a decision between several possible representations of the world. But there might be a case in quantum mechanics for another kind of indeterminacy, where this trick is not possible. And that is what Skow will call deep indeterminacy. And so the idea is pretty simple. That is that there is sometimes no fully coherent assignment of truth values compatible with the real world. So there's no as possible world that does the job of being compatible. So the indeterminacy for these shallow ones came from there being multiple as possible worlds compatible with reality. In this case, if there are no as possible worlds compatible, of course you cannot say that it's a case of indeterminacy in the shallow sense. So you need to do something else. I'll read some quote from Skow. Some presentations of the orthodox interpretation of quantum mechanics make use of the notion of metaphysical indeterminacy. They portray reality itself as fuzzy or indefinite. Place a particle into a box with infinitely hard walls, wait a while, and then look to see if the particle is in the left half or the right half of the box. According to the orthodox interpretation of quantum mechanics, the complete physical state of the particle before you look in the box does not determine whether you see it in the left half or the right half when you look. Instead, the theory assigns a probability greater than 0 but less than 1 to your finding it on the left half, and a probability greater than 0 but less than 1 to finding it in the right half. The orthodox interpretation says that if the complete physical state does not assign probability 1 to the particle being found on the left, and does not assign probability 1 to the particle being found on the right, then before we look, it is indeterminate whether the particle is on the left or on the right. Of course, after we look, then it will become determinate, but before we look, this is a case of a quantum superposition where it seems to be neither on the left nor on the right. It's in a superposition of the two states. So this is a case where you have indeterminacy. That's if you describe it like that. Of course, there's other interpretations, but if you describe it like that, it seems a pretty clear case of indeterminacy. Whether this is what quantum physicists actually believe, that's another matter. But if you take this picture to be the correct one, then that is a case of indeterminacy. And then he uses the Kochen-Specker theorem. I'm actually not sure why you need the Kochen-Specker theorem. It seems like plain Heisenberg uncertainty could be enough. But the Kochen-Specker theorem is a theorem that states that in a Hilbert space of dimension 3 or higher, it's impossible to assign values, 0 or 1, to all binary quantum observables in a way that respects functional relationship between observables and is non-contextual. So that's not the context that defines that value. It is related to Bell's theorem. It's basically the idea that there is no set of fixed values for such cases before the measurement. For specific cases, of course, there is, if you find yourself in a determinate case, but in general, there are quantum states that are not where you cannot find these hidden variables that would be the ones that were there before the measurements. So we're also related to the EPR paper and so on. So the crucial thing here is that if the propositions of quantum mechanics are the statements about observables being having certain values, and it's true that no full specifications of all such propositions can be coherent according to quantum mechanics. Of course, this is a big if those are the propositions of quantum mechanics. But that is at least what the orthodox picture seems to tell you. So concretely, there is no single ersatz possible world for that language that is compatible with the real world. You can either, and this is Heisenberg uncertainty, you can either fix position or fix momentum, but it makes no sense to fix both. To have precise values for both, you will be in a superposition state automatically if you completely of momentum when you fix the position. A sentence that says this is the position of the particle, this is the momentum, cannot have a true value. The sentence that does both cannot have a true value. That's incoherent with the basic formulas of quantum mechanics. So that is an obvious case of indeterminacy, but not just indeterminacy, but indeterminacy that cannot even be resolved by just saying, there are several ways the world can be that is, or no, the way that language is specified that is compatible with the real world. There is not even, it doesn't even make sense to fix a complete ersatz world. Ersatz worlds are always complete, and they cannot be complete. They must lack, if they specify one value, then they will have superposition for the other value. So this is pretty interesting phenomenon. Even if orthodox quantum mechanics is completely wrong, then still the phenomenon that there might be several ways to look at the world, each of which gives you a coherent classical picture, but there is nothing that completely allows you to specify everything. So you can look at the momentum, no problem. You can specify completely the momentum of a particle, and that can be a sort of perspective on reality. You can have a perspective on reality where you fix the position. That's also perfectly fine. It's classical. It's all these sentences that are all about that. They fit in a Boolean framework. There's nothing non-classical about it. But the entire language, all the properties of the system, they do not fit in a Boolean language. So while in the picture of the shallow ones, we have Boolean pictures, but there are several ones that are compatible with the world. Here, there is no global Boolean picture, but there are local Boolean pictures that are compatible with the real world. So now, truthmaker semantics. To try to make this precise, because Skow proposes a problem, but he does not provide a formal model to solve, that is of the strength of the supervaluationism, to deal with that. Some other authors like Toza have done parts towards semantics, but as far as I know, there is no good formal model to deal with this phenomenon. And it seems an interesting phenomenon, whether quantum mechanics is right or not. And I think truthmaker semantics may help us here. So what is truthmaker semantics? It's for those, because I explained this already a lot of times in talks here, but those who, so sorry if I'm boring you, you can always stop me, but it's the idea that sentences are not evaluated at possible worlds, like in ordinary semantics, but at parts of the possible worlds. So we basically, I like to think of it as information containers, and we call that states. And those states can make sentences true or false. The sentence, it's more than 25 degrees temperature here, is made true by, I guess, an information container that consists of information about the molecules that fly around here in the room or something like that. Well, usually in classical semantics, you're going to think about how is it verified, the sentence? Well, it's about this actual world where it is true. So the world being the complete specification of all properties in the full entirety of the universe. And they can contain just as much information as is needed to make a sentence true, and not more than that. So, specifically in the exact form of truthmaker semantics, but we won't today go into the distinction between exact and inexact. But the idea is that verifiers should be wholly relevant there to the sentences that they verify. So we don't look at the full possible world, but the parts of the possible worlds that we actually use to make that sentence true or false. What are the advantages of going truthmaker semantics? Well, there's a lot of them, but worlds obviously contain a lot of redundant information, that might be completely irrelevant to the problem we're dealing with. If it can be done without that, that seems to be an advantage. Certainly because parts of the world are much more easily handleable, being able to be handled by agents, like artificial agents or human agents. If we have to talk about the possible world, that's like an inconceivably complex notion, this complete state of the universe. But the nice thing is, if we talk about indeterminacy, is of course that indeterminacy is like baked in there. I mean, because we're talking about truth or falsity at states that just contain some information. Of course, this is not going to fix every truth value of every sentence. That's just the basic case. Everything is indeterminate. It's just like these weird extreme states where we have everything, that everything will be determined. But a big part of the whole truthmaker universe, let's say, or truthmaker model, is indeterminate. Indeterminacy is not like an oddness here, but it's everywhere. And still, this can be seen as semantics for classical logic. So it's not because you go to truthmaker semantics that you have to get rid of classical logic. And I think the issue is more complicated than it's sometimes portrayed in the literature. But there are good ways to present it as a proper semantics for classical logic. Of course, this doesn't mean that now we have solved the problem of indeterminacy because everything is indeterminate, there's nothing special about it. No, of course, now we then should make a distinction, like how can we in such a model make a difference between the epistemic case, the linguistic case, the deep case, the shallow case. That is not at all evident just by like generalizing your semantics, but at least there's room for it. It's not a priori excluded. And there's also no reason that I see why this would be inferior or something to possible world semantics. I've always been saying here, classical logic says this and that, but classical logic is just a bunch of rules. You can then still choose which semantics you choose, in my opinion. You can have model theoretic people who think that for classical logic you should also believe that that the model theory, the standard model theory is correct, but I think that's a minority today. Another advantage of this way of viewing is that we have much more fine-grained notions of content this way, because this is not the topic of the talk, I won't go into that too much. It's just good to say, I like to see it as the fact that with possible world semantics we get a good idea of where sentences are true, at which worlds they are true, at which times, at which points in a frame, and so on. Where are the sentences true, or where are they false? In a truthmaker semantics we get a model for why they are true or false. Say you have a tautology, P or not P, that's true everywhere. And this tautology, Q or not Q, is also true everywhere. So these have exactly the same locations. The awareness is the same for all sentences, for all tautologies. So if you are a classical possible world person, you have to say that they express the same proposition. There's no difference in content between those. If you are coming from a point of view of truthmaker semantics, you can, or any hyperintentional idea, you can say, no, but why is this one true? Like, what is the answer to a why question about them? And then you can say, well, this can be true because P is true. It could be true because not P is true. And I think it can also be true just because there's nothing at all, because it's a tautology. So there are 3 reasons why such tautology can be true, and it's 3 different reasons from that one. I mean, there's one common reason, namely nothing at all. But there's also different reasons, and so there's possibly different answers to the why question associated to those propositions. So I think that's a good argument to say that those propositions must have different content. How otherwise we can have different answers to questions about them. if they are really the same, they should be perfectly intersubstitutable everywhere, also in the scope of why questions. A hyperintentionalist will say, no, we cannot do substitutions in all contexts because there are hyperintentional contexts where, and that's my formulation, the why question becomes important. And with truthmaker semantics, you can do this because you can have P states, you can have not P states, you can have the empty states, and they are the truth makers of that sentence. And there's other truth makers for Q or not Q. So tautologies don't have to be the same, all of them, and this makes you, this gives a more fine-grained notion of proposition of content. So an intuitive example of how we can use this for indeterminacy. Look at the sentence like the temperature will reach at least 18 degrees tomorrow in Louvain. This is a true sentence, most probably, it is made true by some information about the period of the year, the basic climatological information of this part of the world, and so on. That could be a container of information, a state that makes the sentence true. But then we can say, is there such information in the real world now for this sentence? The temperature will reach 26 degrees tomorrow in Louvain. Or maybe make it 27 or something. You could say this is open. If you believe that the future is open, you may say that actually no, this is not determined yet. This may depend on some indeterministic phenomena, probably not, but there's discussions about that. And so now you can say, well, while certainly this state that we already originally had about this climatological information and so on will be ignorant about the truth value of that state. But then there will be another state, if you believe that the future is fixed, that will make that one true. So you can find richer or other states that can fix your truth value. Then you don't have deep indeterminacy, then you don't have ontic indeterminacy. This is plainly a case of lack of knowledge. We don't have enough knowledge to know whether it will be 26 degrees tomorrow if the future is not open. If the future is open, then we will not even find another state where we can fix this. So whether the truth is open, the future is open or not, this sentence is undetermined. This sentence is undeterminate in its original states, but it is ontically undeterminate if we cannot find another state that does the job of fixing it. So that's the difference between an epistemic kind of indeterminacy, where it's just lack of information, or where we can find another state that does fix it. And if that doesn't exist either, then it's a case of proper indeterminacy. Okay, I'll go a little bit faster. I was going to just the technical overview of truthmaker semantics is not important here. But what is the model itself that I wanted to present? Is the idea to divide the language into coherent fragments. Think of sets in the quantum case, sets of coherent or commutative observables, or languages about those observables. And just make your language, your total language, be completely exhaustive of those sub-languages that provide different perspectives at the world. You can look at the world from the perspective of momentum, you can look at the world from the perspective of position or something in between the two. There's a lot of you can also think about it outside of quantum mechanics. You can look at the world from a perspective, a subjective perspective, an objective perspective, and you use language that is partially coming together. So both the one who looks at the language, at the world from his own perspective, will say stuff about tables and so on. But the way they refer to themselves or something, or to others, will be different, and maybe use different vocabulary for that than the one who looks at the same situation objectively. So it's these cases where your language can be seen, can be made precise in different ways, and they partially overlap. It's not a case of simple levels of description or something. It's really where you talk partially about the same stuff, but it doesn't make sense to completely think of it as one language that can be coherently interpreted. That is the basic crux of the matter, and all the rest is just formalism, I would say. So divide the language into coherent fragments, then provide some states that are quite the usual ones you would expect in a truthmaker semantics. Then you have some notions of a state being complete. Usually that would be if it fixes the whole language. If it says for every sentence in that state either the sentence is true or the sentence is false for every possible sentence. That's what a world state would be in the truthmaker semantics. Here we say no, a sentence state is already complete if it completely specifies such a coherent fragment. So not the entire language, but part of it that is supposed to be coherent. Because you cannot get to the complete language. And then you can say that it's F consistent for some fragment if it's only verified. If it only verifies and falsifies statements within one coherent fragment, F, and it does not include both a verifier and a falsifier of that same sentence. So that's also more rigid than usual truthmaker semantics. And then, very important, a notion of admissible extension for a fragment. For each coherent fragment, F of the language, there is a binary relation that specifies whether an F-consistent state S1 that includes the state S2 is an admissible extension thereof. So remember, there's not all information already there in states. States lack information, they just have some information there, but about most sentences they don't even talk about. So we can make them bigger. We can add information to them, and we can add information to them in the direction of one fragment of the language, or we can do it in the direction of another fragment of the language. We can look at this table, which is could be one predicate table that applies to this object. We can look at it from an objective and a subjective point of view. So information about this table could then be understood in an objective way or in a subjective way, depending on how you increase your states. Yeah, a very important point, what super true and super falsity would be, is not visible on my slides, because I did not properly prepare. But what it says is that something is super true in such a model, if there is one consistent fragment of the language, such that all the fragments F, such that F admissible extensions make it true. So it's true if it's true in all ways to make it precise, let's say, given that sub-language, then that's okay for supertruth. So you should fix some fragment, and there it should be whatever you do as an admissible extension, it should be true. Then it's super true. I won't go into the specific way it's done for quantum theory, but you can trust me that, or maybe you shouldn't trust me, but for now, temporarily, you can try to trust me, saying that, that's an introduction to quantum mathematics. You can believe that you can nicely embed the Hilbert or the von Neumann formalism into this framework. of course not completely independently, we still need Hilbert spaces and so on, but for example, the consistent fragments will be those that are only about commutative observables, mutually commutative observables. States are sets of linear subspaces of Hilbert space that can be put together. Admissible extensions have to do with the fact that a measurement can end up in such a state. So you have an indeterminacy, you do a measurement, you use the border rule, the system will end up in an eigenstate of the observable that you've been testing. So that's the kind of things that are true in those eigenstates, or the truthmaker version of that one, will be admissible extensions. So if you're in this box and you don't know where your particle is, or your particle is in the superposition of being on the left or the right side of the middle, as in the example of Skow, then it will be indeterminate, and there will be, for the position observable, admissible extension where it ends up left, and there will be an admissible extension where it ends up right. So things like it has a position within the box is going to be super true. Also, it has a momentum will be super true, but not that it has this momentum or that momentum, which is what quantum logic gives you. So the results you get out of it are same as standard quantum logic, but the model is different. And then to round this up, and I think I will have spoken for exactly 1 hour. So can there be applications beyond quantum mechanics? I believe there could be. So of course I set it up as a way to deal with ontic indeterminacy, but evidently there's no reason why this could not also be used for just vagueness. And it could be, but this is like I didn't do linguistic studies of this, but while supervaluationism works super well for these kind of scalar notions, where there's like this flat line of a spectrum and you can end on both sides, but this is a completely arbitrary thing where you put the border. Now there might be cases that are much more complex than that, where things like a word like mass as used in a non-specified context. Of course, if you are in a specific physical setting and so on, but mass is used much more broadly in biology or something. It's part of a whole theoretical framework, theoretical backgrounds, theoretical underpinnings that specifies what mass means. Temperature, maybe love. You can look at love from very different sides that are each of them maybe coherent, and all of them together constitute the concept of love. But you could say that there is no completely. So if you talk about the love between a parent and their child, or the love that is like a metaphysical sort of love, where Alexander was talking about recently in my office, about essence, or whether it's not about the properties of a person, but about the person itself. So even if the person changes all of its properties, if the relation still, the positive evaluation still holds, and there would be love and so on. There might be different ways to define love, and strictly speaking, they are part of different languages. Of course, there will be vagueness too about that, and you can use the words in maybe. But you could also say that, what was really going on here is that the kind of precise way that you can look at these concepts, they do not all live together in one big languages. It's all several perspectives to look at the same concepts. Maybe, yeah, it's doubt whether it's really the same concept. That's a big discussion, but it might be interesting to see whether there's not some complex cases of vagueness where the simple options are not working, and that a complete classification of the language at hand is maybe not useful. So that a solution like mine would work better. Cases of deep paradoxes, where you have Zeno's paradox or something, or the liar paradox, and some things don't seem to get a good fixed truth value. There's keeps on discussion, like those say that, and then you can say that. And what about us saying, well, those answers are both right, but they live in a different conceptual framework, and they make it precise in different ways. And maybe they agree on some points. Maybe they are both talking about the same world, but they are then, on top of that, introducing some different language. So different fragments, different, you could say, maybe magnifying glasses by which you look at the world, and it looks differently, but the concept exists beyond those specific ways you look at the world. So that's cases that maybe could be dealt with. Cases of mathematical indeterminacy that go beyond a single theory. Like you can of course say, yes, ZFC does not fix the continuum hypothesis. So that's a simple case of, well, there are two models for ZFC, and one where the continuum hypothesis is true, one where this is false. That fits perfectly with the shallow determinacy picture. But you could also say, well, basically the way we describe those models is kind of fishy. If you look at the way a mathematician describes their models of set theory, that's in nowhere similar to like having propositions and you fix just the truth values one by one. It's gigantic. You cannot do that. You need a theory to describe your model. You're not talking about the model directly. You're doing it via a theory. You're accepting ZFC, for example, and then you're going to construct with ZFC those models for ZFC. Of course, the fact that you're doing it within a theory makes that your models are not sort of stable, independently existing units. So maybe you should look at it from the point of view, well, maybe they live in other languages too. Maybe there is a way, a sort of language, a way to make the world precise, where the continuum hypothesis is true, and then there is one where it's okay to where it would be false, and maybe they are not coherent at all. Those two. I mean, of course they're not coherent. They disagree about the continuum hypothesis. Maybe their language and their basic presuppositions are not even coherent. So there's incommensurability, and it's for those kind of cases that I think a model like the one I presented could be interesting. My time is up, so I will stop here. Maybe just one last thing. Cases where you have multiple scientific idealizations of the same real-world problem, say climate change, and you use different languages. So you look at the climate change from the perspective of oceanography, you look at the problem from some other discipline. You partially talk about the same world, evidently, but you also use completely different languages. And your models, your idealized models, they disagree. Like the oceanographers, some models make different presuppositions than others, even if they speak the same language. So you have indeterminacy even at the level of the idealist models within one language, among those who work in the same theoretical backgrounds. So there is already indeterminacy there, but the problem is broader. The problem exists outside of those models. And other scientists who speak a different language also look at that problem and might also find indeterminacy. And maybe it's the totality of all these different perspectives that give us the best way to look at the world as it is, and not to pick one or to think that there is one coherent description of the entire world. Okay, that was my talk. Thank you very much.
Cool. Take 5?
Take 5.
Take 5. questions, thoughts?
I think I missed one part of your explanation about truthmaker semantics. At some moment you say something like any kind of truthmaker semantics is essentially indeterminate. I think I just didn't understand what you meant.
Oh, just the fact that so you evaluate sentences at states which contain some information but not all information. So if I have the state of information that describes the features of this room, then that will be indeterminate with respect to any features of the outside world.
Okay.
So in that sense, of course, you have these world states that are like maximal states, but they are like rare animals. They are not the core of the semantics. So most of the thing is just indeterminate, not deterministic, indeterminate by nature, but not in a problematic way. Not that that would be that's a feature of the system, but it makes it specifically interesting for looking at cases of real, more interesting indeterminacy, in my opinion. But that's all, it's not deep.
Yeah, okay, I think I just missed that. And I had another question also on truthmaker semantics. You said that you like to think of it as of this idea of information boxes. I was just curious, what is information? Is it defined somehow independently from the fact that this is something which allows us to infer truth values of the statements, or just the way to rephrase it?
So, of course, the advantage of the word information is super vague. But it is intuitively pretty clear.
Okay.
So it's like it's not linguistic, but it's not about stuff either. It's like this level in between. And while maybe it may be difficult to think of, or it might be a very heavy metaphysical question of whether there are things like states of affairs and so on, because that's how you could also read what those states are. But it's super useful in the truthmaker semantics to think about inconsistent states. And I mean, an inconsistent state of affair existing in the world or something like this is, but that we can put together inconsistent information. I mean, that seems kind of intuitively appealing.
Yeah.
And there's information in all sciences and so on. So it's of course fake, and I don't mean this to be in any way really fundamentally clarifying, but it captured this intuition of what is stored in there is not worldly, but it's not linguistic either. Mm-hmm. It's like in this level in between, and it should be globally applicable in all kinds of sciences and but it should also go beyond just the linguistic representation. And I think information has these features. And then, of course, you have to give a theory of what information is and so on, and it would make it super complicated. But it's more about to get the intuitions right. Mm-hmm. And it's a way that people have consistently talked about it off and on. In truthmaker semantics, I guess the first really worked out logical version was by Kochen-Specker as a semantics for relevance logic. He didn't call it a truthmaker semantic. He doesn't call it truthmaker semantics now. He don't see any connection himself, the man. But I mean, it's a very similar kind of framework. And in these relevant contexts, it is since the first semantics that people have developed common to look at, to call it like databases or states of a database or states of information. That sort of language is quite common in literature. So it's not that I own that way of looking at it, but I think it's insightful, more insightful than in directly looking for a precise way to determine what a state would be. I mean, it's sort of the semantics itself is supposed to be the formal model. If you're going to like stick heavy metaphysics on aspects of this formal, that's not a formal model anymore. Then you put extra stuff in there. No, a state is just whatever it is structurally speaking inside this model. But just for us to give it a picture, I think information is at the right level.
Okay.
Thanks.
I have a few. First, more a question of precision because I don't know enough. In what way your notion of fragment of language is related or not to the situation semantics of Perry's, for example?
So that's also it's not a truthmaker semantics in the sense that we don't talk about fusions and so on. It's not exact. I mean, there's some disadvantages of that framework, but that's also a predecessor of this same framework. There are several like pioneers. And as a truthmaker semantics, with that word, I think it was Bas van Fraassen who made the first truthmaker semantics, inspired by Barry and so on.
But the goal is not to have fusion and to be more general.
So the goal in this exact truthmaker semantics
that you have that situation.
is so. If you look at what makes a conjunction true, and I skipped the clauses for the connectives, but if you look at what makes a conjunction A and B true, well, in truthmaker semantics today, we say that it's the fusion of the things that make A true and the things that make B true, or a thing that makes A true and a thing that makes B true. If you put that together and you presuppose a mereological structure of those states, then you have a truthmaker for A and B. And this makes it so that you keep the information, that you have this structured information up to very complex states. While in a more ordinary sort of situation semantics, you don't keep this individual parts of the information as you have longer conjunctions or something like that. The more natural way to read the conjunction would be the states that make A true, or situations that make A true, and the intersection with the states that make B true would be the states that make A and B true. That's like a much more natural, more close to classical logic way of dealing with smaller situations or states or whatever. And the disadvantage of that is that exactly you have to, all your states should be fully containing already the full information, so to say, from the first part, because you get the A and B contains information A and information in B, but if it's the intersection, then it should already have been in the situation, and so you basically don't have this ability to specify the size and the way you can add pieces of information to it, and there's other disadvantages. I mean, but it's the same project basically, and the situation is for me just as much as a state as an information container, a way to intuitively make sense of what a state is. So the situation is fine for me.
I have a following, but
Yeah, go ahead.
okay, but so that goes to the example of quantum mechanics, because what is great for you with the Hilbert space, it's superstructure and you can isolate mathematically your fragment of language. But when you were talking, I was thinking about the thing you said at the end. You know, if it's a multi-scale modeling, so you model a piece of iron at a certain scale, blah, 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 another scale completely different, another scale things that were true are not true anymore. And there you don't have as much as a good mathematical way to at one point it will superpose and you will have to make a choice, what is true, what is not true, which one is okay. So how will you deal with it? You will add some vagueness to the thing, or how? Because I like the example of the Hilbert space because it's a very clean example, so it's a good example to think. But
so I was thinking about cases like that actually, and so I don't know whether it's exactly structurally similar, but I was thinking about cases where you have like different grain of seeing an image. So you could have a picture done with 16 pixels, and then a picture with much more, and they all seem to give this. I mean, that seems to be the kind of thing that I would like to capture. That you can maybe have several ways in which you can like coarse grain the information in a picture. And also several levels of doing it. And if we want to say what is true about the picture, we should like be open to. I mean, we should use the information in the other ways we could look at this. I mean, we could coarse grain it, or fine grain it, depending on how you look at it, and. So it seemed to me that it would be kind of doable. Of course, these fragments would be probably an infinity of fragments of the language. Like talking about pixel 1 is not the same as pixel 1 and the other fragment and so on, because you look at it in a different way. And then you have to see like, oh, I have a super coarse-grained image. I try to make it a little bit more clear what's in it, and I do it in different ways. And these would be different admissible extensions. I have some information in my coarse-grained picture. And by looking at several ways to make it more enhanced, I get more information. That's how I was thinking about it, and it seemed to. I mean, I haven't worked it out, but
one of the interesting difference with the picture is that at least the picture I can say every pixel is fixed. So some reductionists could say, okay, it's all fixed, but it's just different perspective on the same thing. But for steel, for example. The flexibility of steel does not appear at the mesoscale or at the microscale. It's a crystal. But if you do a sword and you just, what's the word for that? You bend the thing, boom, 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 bend the thing, boom, boom. What they all do in movies and all that, you get to the flexibility at macro level. So there's properties that are not just not there at all at certain level. And other disappear, and other appear, and it's the same damn thing. You know, it's the same object we're describing. So I thought that was maybe also a good example, less clean than quantum mechanics, of course, but it's part of our description of the material world, you know.
Yeah.
Steel is flexible only when you have a chunk of a certain size, or
Right.
it's a crystal. It's very rigid. And there's all kind of properties of mechanical properties that are like that. They are scale dependent in the description.
It's a super interesting case. I don't see why it would be so problematic. Maybe you will not get much out of it in the sense that indeed it's so different.
No, but I'm not saying it's problematic. It's just it seems more complicated than
Oh,
the
yeah.
picture, except if you have a notion of information in the picture, where I could see. Yeah, at certain level you don't see anything. At other level you see, oh yeah, it's a duck.
Right. Yeah. So. I mean, it's an interesting case. I can't say much more about that, but I would like it to be. It seems like one that I would like to be modeling. Yeah, and I see that it's less structured than the Hilbert space, evidently. But
Yeah, but it's not a problem, it's just structured. Life is like that.
yeah. And I mean, it's really so the notion of super truth that I have here just says like there should be some fragments in which you all accessible, all admissible extensions cohere. I have the same opinion about that truth value. So if that's pretty flexible, I mean, you can then still say it's bands or this metal bands with these properties because in the bending in the macroscopic part of my language. There, I have an extension where it clearly, like my only admissible extensions are such that it bends. That there are like levels where I don't have even this property of bending, that makes it fit exactly nice for this kind of model.
Exactly.
So I don't have to like have every information specified. Like, it's the opposite. That is what the model is fixed for, that it's perfectly fine that my quantum state does not say anything about the momentum. That might still be good enough to say that it actually has momentum.
No, but it wasn't a critique, it's an advantage of your approach, because the example of multi-scale modeling, it's something that people puzzle a lot about, because they say there must be something that corresponds in the world, and you cannot have flexible and non-flexible at the same time, depending on the scale. How does it work? If you have a notion that is much less strong than the possible world, of course, it seems better.
Could you send me some references to that literature? Because that seems.
But even it's an example that Batterman really likes.
Okay, that's good.
Because he says, because he's obsessed by sword. the way you
That's correct.
The way you manipulate the steel in a sword, you can have very different property macroscopically, and that in microscopically it's all the same. But it's the way you build the sword, and it's very surprising because there's a huge different flexibility between a Japanese katana and a Crusader sword, and it's steel. It's the same kind of steel. In the way of building it, and of course for him, the coarse graining description is really important in his philosophy about limits in description and scale dependence.
I should get into that literature. Yeah, thanks a lot for the suggestion.
Any questions? I'll dive in. I was wondering, is there a I'm just always interested in this kind of landscape around quantum logic. Is there?
No, but the cool part is that it's not quantum logic.
Well, exactly.
It gives the same results.
Well, no, but that's it. So is there something interesting to be said? Because I know there's the reduction from quantum logic to B.
I didn't know that existed.
Yeah.
What logic B?
Yeah.
Oh, nice.
And so that got me thinking. Like, I wonder if there's some kind of an
Quantum
analogy.
logic in which sense? Because the word itself is super vague.
Yeah, and I'm forgetting which exact formalization of quantum logic. It's a Goldblatt paper from the 50s.
Cool. I should look at that. I didn't know that.
Yeah. Yeah, so that got me thinking about there's it's cool how many alternative semantics actually wind up working for quantum logic, which is really kind of interesting to me. I mean, not that not that I know this is less surprising to logicians because you guys are used to this idea that like, yeah, sure, there's lots of ways to write stuff down. But something about this I've always thought was really cool.
And at the same time, there is something weirdly specific about quantum logic that I never really liked. So it's like you have to like this orthomodular properties that you don't have to take into account in any other logic. And so if you want to reconstruct quantum mechanics from quantum logic, like it seems super ad hoc the way people try to avoid just like defining defining just Hilbert spaces again and basically doing the whole classical thing all over again. There is something like it would be super beautiful if we could just like have some generally appealing logic, a logic that's like maybe this idea that you can say there's several ways we can look at reality and that gives different way in which we specify truth values and then you on that basic philosophical idea you build a logic and then if you could use that logic that is independently justified to build to say something useful about quantum mechanics, that would be much more appealing than the way it's done till now, where we have the nice formalism by von Neumann, and then we like see, but this like gives rise to some weird non-classical logic, and how we can get so as far as possible from these Hilbert spaces, but still keep the ideas more or less intact. I mean, it's like sort of. It would be cool if you could go the other way. Look at it, give some insight from more general ideas to go to shed a light on quantum logic, quantum mechanics, rather than take quantum mechanics and think that you can sort of derive a proper logic from it, and that would have any like metaphysical value or something.
Wasn't the project of Eisenhart, the Brazilian Eisenhart, the quasi-sets that was supposed to be justified in general, and after that, that's the structure of mechanics. I don't know.
There are things like that, but it's while I like that formalism, it is very much also extremely technical, where you like sneak in a lot of formal stuff to have you have a basic intuitive like appealing idea of quasi-sets, and then to get to something that is really useful for quantum mechanics, you have to at some point make rather complicated mathematical constructions, and you like wonder, well, we could just have done it like traditional quantum formalism instead of using quasi-sets.
Fair enough.
But no, that's really helpful for the motivation, though, actually, because that is, I mean, if you find the truthmaker semantic approach appealing from the get-go, and it's going to help you with other kinds of vagueness and indeterminacy, then what happens when you bring it here? That's a really nice way to think about the project. And then if you sort of quantum mechanics falling out is not unexpected, but it's a cool bonus. Like it shows you that you're on the right track, that you're really you're capturing the phenomena that you thought you were capturing, because if quantum mechanics is sort of the granddaddy of the indeterminacy phenomena, then if you're grabbing that, then you're grabbing the thing you thought you were grabbing.
Exactly. And to be completely honest here, I don't claim at all that this is like some sort of complete description or complete set of models for quantum mechanics or for quantum logic. No, it's just that you can describe one of the models or a series of the models that respect my criteria. Give exactly the predictions that you would, or what you would expect from quantum formalism. So of course this means that it's not, I mean, that doesn't mean at all that it's complete. Maybe there's a lot of information lacking, but that is also kind of the intention. I don't want to say that this says everything there is to say about quantum mechanics. Just that quantum mechanics is compatible with it, and that the kind of indeterminacy there is a kind of indeterminacy that can be studied through this lens. So, I mean, I don't want my project to look too ambitious or something. Or
No,
too,
but still, no. I get the point. It's
cool that it's cool that it's a way to deal with quantum mechanics and then also other stuff. But it will not replace quantum logic, because I build those things in by hand. I say,
Right.
well, now our states are sets of subspaces of Hilbert space. Yeah, I mean that of course presupposes a whole formalism. It's not that I even have some hope that this would give another perspective on quantum logic.
Sure.
If Bricmont was here, he would say it's all epistemic anyway. So.
Yeah, but.
So yeah. I don't agree with his position.
But it's okay that it's epistemic. I mean, if you're a Bohmian, like he is, I guess.
He is.
I mean, then that's what it is. But then you should make that point completely precise. And then also a good way to look at indeterminacy would be nice. Like also there we have a lack of information, and that can be captured by such a semantics. So. Basically, because the project is not metaphysical, I think it should be of interest to him just as much as to the orthodox quantum mechanics.
Good point.
Any further questions, or possibly on the internet?
I have a last one. But
Yeah, go ahead. Go ahead. We have a few minutes.
Reading your talk, I was thinking about the weird Wilson semantic of facade in Wandering Significance.
Sorry.
Yeah, because he has something like you, but there's a case that I don't know. So he says, okay, there's zone of reference that works, zone like that. But okay, so it's called it the theater model. So the spectator is here, and the back of the scene is here.
Okay.
So he says, suddenly you have another language fragment, and of course in this zone, since you're here, you don't see this one anymore. This one replace. So they superpose, but they never are applicable at the same time. It's because if this one was not here, these would be the right way to refer. It's just when I had this other fragment, it replaced part of this one, and the frontier moved to here. And after that, he said, language is very complicated, but there's only one okay at any time in the perspective of all the language, but it could move. If we learn stuff, we model physics otherwise. And I was thinking about the dynamical part of these fragments, because you made the semantic, you said, okay, I have a problem, I built my fragment, blah, blah. But how, maybe you're not at that step, but how could it change if I add information or if I lose information? Because that's a very specific, weird dynamics. I don't remember the justification. It's an unreadable book.
I still feel like I have to read it. So.
But there was this idea that there's a coherence at any time, but not true. No diachronic coherence. But language is fragmented in zone, which are coherent from the point of view of the spectator at any time, but it can move. You can move a decor, move a facade. You learn new stuff. He claimed that it's extremely efficient for multi-scaling modeling. I don't know, because it's difficult to read Mark Wilson. I was thinking about the dynamical part of the.
I have not thought about
diachronic
that.
part of fragments. You learn stuff. You forget stuff.
Yeah, no, that's a very good question. I haven't thought about it. So, I mean, in my old projects in logic, it was always about dynamic logics. So it's a very natural question to ask. But I couldn't come up with.
Okay.
I'll definitely think about it. Thanks so much
That's
for
a
the
question.
suggestion.
That's a question maybe that need a beer.
Yes.
That seems reasonable.
Thank you.
Thanks
very
so
much.
much.